Good morning and welcome to Litmus Test. We're back for the final video on chemistry math, and today we're going to be looking at the second reaction, turning bronze ingots into tools, and we're going to answer this question: how much copper or tin do I need to make one stack, or 64, of each tool? How much copper or tin to make one stack of each tool? Last time, we addressed the question of copper and tin reacting into bronze. And we worked out this math, a bit ugly looking, but we said that's how much it takes to get, bronze. We did not address the final conversion of bronze into our tools. So let's do that real quickly here. We'll set that up. We know that it's going to take 3 bronze for every bronze pick. And we know that it's going to take 2 bronze per bronze sword. And we know it's going to take 1 bronze for every bronze shovel. Easy, yeah, we got that already. So if we know that we have some number, say 12 bronze, how many swords can we make out of 12 bronze? Well, 12 bronze, and we want to turn it into swords, and we want to get rid of bronze. So we say for every 2, since we're using swords, for every 2 bronze, we get 1 sword. In other words, 12 divided by 2 times 1 equals 6. We'll get 6 bronze swords out. Okay? Let's start again, but 12 bronze into picks. Well, we have 12 bronze. We know that for every 3 bronze, we get 1 bronze pick. So 12 divided by 3 times 1, 4. 4 bronze picks. Hopefully that was very, hopefully nobody's going to argue that. We can test it real quickly just to make sure that that is correct. So we plug this in. And let's give ourselves, actually, what am I doing? My bronze is right here. We'll cut ourselves down to 12 bronze. 12 bronze. Look at that. I don't have to plug any more in. I know that if I had enough sticks, I could use it to get 4 picks, right? Very straightforward. What if we have, well, look at that, 6 swords. You know what, we can just put all the sticks in and we're going to get 6 swords out. So you can see how the math works. The math is just doing something, the same sort of stuff that we'd be doing here, but a little differently. It's very important to throw away your crafting tables, don't worry. So if we have a certain amount of bronze, we can easily figure out how many bronze picks we're going to get. So, big question. How do we solve the whole problem now? Well, using 12 bronze, if this is the setup of the question, if the question says you have this much bronze, how many picks? Then we knew that we would start with 12 bronze divided by 3 bronze per pick. In other words, we said that the goal is at the end. Whatever information we have to start with is at the start of our problem. And then we can just type all this in and push enter. 12 divided by 3 times 1, enter, 4. 4 bronze picks. Now we do have to watch our units and cancel everything correctly. That's not a big deal. So let's look at the, you know what? Let's start a little bit simpler. We're going to start with the shovel. The shovel is where I'm going to start because the shovel only takes 1 bronze per shovel. So easiest ratio. And we're going to start with the tin. Because again, 1 tin, 4 bronze, an easy ratio. We know that we need to find 1 stack of stuff, right? But that's kind of like saying we know how much we're starting with. We're starting with 1 stack of bronze shovels is what we're, quote, starting with. Even though it's what we're trying to get, it's the information in the problem that we have to go on. And what we want to know is how much tin. So when we set this up, we want to start with 1 stack of bronze shovels, and we want to turn it into tin. So we kind of have to work backwards here. We know that we've got 1 stack of bronze shovels. Let's do that correctly. We know that for every 1 stack, we get 64. And we know that for every 4 bronze, we only need 1 tin. So 1 stack, 10. Let's see what we get. 1 divided by 1, easy, that's just 1, right? Times 64, that's going to be easy, that's just 64. Divided by 4, come on now, times 1, that means that it should take us 64 divided by 4, 16. 16 tin to get what we need, right? Let's make sure that that makes sense. Okay, let's go back and check our math. We started with 1 stack of bronze shovels. For every 1 stack, we have 64, so that's 64 shovels. And we also know that for every 1 shovel, we're going to need 1 bronze. Now, I didn't write that down because of space, but we could probably stick that in here. You know, 1 shovel per 1 bronze. And then for every 4 bronze, which gets rid of the 4, we get 1 tin. So we just plug all that in. We can just ignore these 1s. We pretty much just have 64 divided by 4. In other words, a quarter of a stack, or 16 tin, ought to be enough to make what we need. So 16 tin, we can even, if we want, convert that back into stacks and say 1/4 stack. Let's clear that, and let's put a sign somewhere. Let's put it here. We'll put tin, and we'll put copper. So, for 1 stack of bronze shovels, we need 1/4 of a stack tin. All right. Now, let's think about this before we go any further. To get from 1 shovel to 1 sword, yeah, there's some weirdness in the sticks, but look at the bronze, because that's all we're interested in, is the bronze, right? It just goes from 1 to 2. There's just twice as many bronze in the sword as in the shovel. So if we want to ask this question that we just asked for all of the tin, if we want to ask it for the sword instead of the shovel, all we have to do is put a times 2 in there. Let's write that down again. Weather. Let's write that down again. We're going to omit some of the 1s. And we'll just kind of pretend that they're in there. So 1 stack of bronze swords. We know that that's 64 of them. Okay, that's fine. 64. And we know that that's actually going to be something, 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 etc. We know that there's going to be 4 bronze. And we're going to multiply, put the times in there, times 1 tin. And we also know that we're going to get, for every, and here's the trick part, right? For every, because we didn't cancel out the sword, for every 1 sword, we need 2 bronze. So in other words, we have the same thing that we did before. It's times 64 divided by 4, get rid of the 1s, times 2. Well, that's just 32 tin, or 0.5 stack. Easy peasy. In other words, to get 1 stack of bronze swords, we just multiplied this by 2, and we got half a stack of tin. If we want to do the same thing for shovel or picks, if it takes 3 bronze, that's just 3 times whatever this one was. So we just do, oh, look at that. We can just, do that right here. For 1 pick, that's just 3 bronze. All we've done is change that times 3 here, and now we have whatever 16 times 3 is, it's 48. Or in other words, 0.25 times 3, 75, 3/4 of a stack. Where am I going? It's right here. So 1 stack of bronze picks, 0.75 stacks of tin. All in all, the total number of tins we need. How much tin do we need in total? Well, a quarter plus 3/4 is 1, plus another half. We need 1.5 stacks of tin. Okay, let's go ahead and make sure that's not going to run on us. We need 1.5 stacks of tin. Let's run through the same math with the copper, but you know what? We don't have to change that much here, right? What do we need to change? Well, we just need to change this ratio of bronze to copper, or tin, to, you know. Let's also do the shovel first. The shovel's easy. We'll just get rid of that extra 1, pretend that that 1 is right here. Just toss that away. And remember that this, instead of being 1 tin, is now 3 copper to 1 pickaxe, and, you know, easy peasy. So now we just have an extra times 3 in here. So what is this? 64 divided by 4 times 3. Oh, we just did that. That was 48. What did we do that for? There we go. That's still another 3/4 of a stack. You see how we did that again? We said we need 1 stack, which is 64 copper. And we know that it's just going to take 1 of the copper, or sorry, 3 of the copper to 4 bronze, but only 1 bronze to a bronze shovel. So for a stack of bronze shovels, we only need 3/4 stack of copper. There we go. And just like before, if we want to turn that into the pick or the sword, sorry I didn't change that earlier. If we want to turn that into the sword, we just say, well, hey, remember it takes 2 bronze to do that, right? For every 1 shovel, or, well, actually we're already on, what am I doing? Sorry guys. For every 1 sword, it's going to take 2 bronze. So we just add in that times 2 times 2. And now what do we have? Well, we have 64 divided by 4, that's 16 times, well, 3 times 2 is 6, 16 times 6, well, that's a bit tricky. Go ahead and get your calculators out. It's this much, right? Because look at it this way. There's 6 of them here. There's 4 there. So we're actually going to get rid of 4. We'll have 2 left over a little bit. So it's actually not that much. But, you know, get your calculators out. Take a look. We're going to have 16 times 6. So 6 16s. That's, yeah, 1.5. I'm right. I know things. I can do some math. So 96 copper equals 1.5 stacks. Okay. Let's go ahead and stick that up here. 1 stack here for the bronze, 0.5 stack for the copper. And we do. Does that look correct? I mean, that should be exactly correct, right? It's just times 2. That's what we did. What do you think the third one's going to be? It's just times 3 of this first guy, right? Whatever 3/4 times 3 is. I mean, sure, we can plug that in here. We can say, oh, well, you know, we want a stack of picks, and it takes 3 bronze to make a pick. You notice all I'm doing is I'm changing some of this around. Now I'm just going to have 9 16s. I don't know why I put the 3 in there. There's the 9. So I'm just going to have 9 16s. Yeah. Well, that's just 9/4 of a stack. 9 16s, it's 128 plus another little extra 16 on there, so that's 134. 144 copper, or in other words, 2.25 stacks. And you can do your math to make sure that that is correct. But again, that's just multiplying that first thing by 3, and what have we got? Well, we have 2.25 stack of copper. So total, how much copper do we need? Well, 3/4 and 9/4, you know, that's just going to add up to 3. 3 plus 1.5, 4.5 stacks copper, 1.5 stacks tin. We don't quite have enough copper in there, but what I can do is I can just put the copper up here and it will be automatically funneled in. There's 4.5, and that hopper will keep this slot fed very nicely, as you see. And so we can start running this. How much bronze do we expect to get out of this? I don't know, there's a question. Remember that we basically multiplied this number by 4 to get bronze, so 1.5 times 4, that should be 6. 6 stacks out of that. And that should be exactly the same as if we multiply this by the 4/3 that we expect to get. 3 on the bottom for copper, 4 on top, so divide by 3 is 1.5 times 4. There you go. So we expect 6 stacks of bronze. We'll be able to make a full stack of bronze shovels, swords, and pickaxes. Now I'm not actually going to make those today. We're going to run low on time first. And honestly, where would I put it? I don't have enough chests for that. I don't have enough space for that. They don't actually stack. We're just going to sit here and we're going to watch this go. And by watch this go, I mean I'm going to magic it to the point where it's, you know, done. So, in 3, 2, 1, bam! Look at that. All of our stuff is finally gone. I've got myself some nice Cincinnati-style chili. Spoiler alert. And here we go. 6 stacks of bronze ingots. Beautiful, isn't it? Is that exactly what we predicted? Is that exactly what we need? Well, let's see here. We said that we're going to need a bunch of stuff here and a bunch of stuff here, but remember, tin is the easier ratio to work with. We had this much tin, get 4 stacks for each tin, so 4 times 1.5, 6 stacks. That's exactly what we expected to get, because in Minecraft, atoms don't get stuck to the side of your flask and cause you to lose product. And in Minecraft, atoms don't just randomly make other crap. And in Minecraft, actually, they kind of do this. Right then, with that out of the way, apologies for the phone call. With that out of the way, let's just finish this up real quick, and we'll be done with the math, because I don't want to redo the episode from the beginning. Took a while. Almost out of graphite rods. Look at that, 28%. We've been doing a lot of crap here. So, in summary, we made 6 stacks of bronze ingots. And that should be just enough to make 1 stack each of the bronze pick, bronze sword, and bronze shield. Or shovel. Gosh. Does that work? Well, we notice that the coefficients of these reactions are 1, 2, and 3. So if we added them up, that's 6 bronze total is needed to make 1 of each of these. If 6 bronze atoms, Minecraft atoms, are needed, then 6 stacks are also needed to make a stack each of these. 1 stack here, 1 stack here, 2 stacks of bronze to 1 stack of swords, and 3 stacks of bronze to 1 stack of picks. This is exactly how your chemistry homework goes. This is exactly how chemists set up problems and figure out how much of this, that, and the other thing they need. Just by figuring out, well, this type of math. Just by figuring out the ratios between something on this side and something on this side. 3 to 1, or, in this case, 3 to 4, 1 to 4, whatever it needs to be. Chemists can work forwards or backwards, either asking the question, if I have a stack of bronze or a stack of copper to start with, how much bronze will I get? Which of these is going to be the limiting reagent? If I have a stack of this and a stack of that. Only when chemists do it, we use the word mole. If I have a mole of copper and a mole of tin, how much bronze am I going to be able to make? Which of these reagents is going to run out first? But we can also ask the question the other way. If we need to make a mole of bronze, we can use this reaction, or reactions like it, to say if I need to make a mole of bronze, how many moles of copper and tin do I need to add? There are, of course, other things to this math that go beyond Minecraft. Minecraft doesn't really have mass or volume very well, at least not in the inventory. And so while chemists in the real world need to use mass and volume and concentration to determine their, to actually measure the number of moles, since we can't exactly count like we can here, where we can count this very easily. We can't count the number of moles or the number of atoms in the real world directly. So we use mass, volume, concentration, pressure, all of these other measurements that will tell us exactly how many atoms are in a bottle. And then we can use ratios between atoms, ratios between molecules to say how much of this bottle or this bottle do I need to get whatever product I'm interested in. And that's how we solve problems, and that's how we do math. It's the same stuff as in Minecraft, just, with a few different words. Moles instead of stacks, but we still care about limiting reagents, and we still care about these ratios. And everything we do is just going to be multiplication, division, and canceling stuff out. So hopefully this has helped you get a sense for the chemistry math. Upcoming videos I plan to do look into some other stuff like crystal structures and concentration, since that seems to be a tough one. So keep your eyes peeled, and as always, thanks for watching, stay safe, and don't catch on fire.